Okay, I'm going to be working the homework here for 7.7 graphs of tangent, cotangent, cosecant, and secant. And the first question here asks us to graph y equals cotangent of x, or sorry, 9 cotangent of x. So the first thing I guess we should note is that when we look at the standard graph of cotangent of x, it should go like this as opposed to tangent of x, which goes like this. So we can automatically here eliminate this one and work on these other three and kind of determine which of these it would be. Now, with cotangent of x, well, let's do 9 cotangent. Let's go ahead and take care of that. That's going to be 9 times cotangent, which is cosine of x over sine of x. That's the definition of cotangent. So we know that when we go to graph this, we're going to have problems, vertical asymptotes, wherever sine would be 0. And we know that sine is 0 at pi, and at 2 pi. That's where sine is 0. And then also here at negative pi and negative 2 pi. So that means we should have vertical asymptotes at those points. Okay. And then we know that for cotangent and for tangent, you'll have x-intercepts for those functions at the middle point in between the vertical asymptotes. So we know that we should have x-intercepts here, 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 here. And then we know it's going to go like this, okay? Because that's the standard shape of cotangent. Now, the only thing is this 9 here. What that does is it stretches it out, so it makes it really kind of narrow. And let's just take a look at these graphs and see if we can tell by looking which of these it is. So in this one, let's see, I'm gonna have to make that bigger. Let me move to the side a little bit. So here we have vertical asymptotes at 2 pi, at pi, at negative. So this one looks pretty good. So that may be it. Let's look at this one here. Let's see. We may have to do a little more analysis on this. Let me make that one bigger. Yeah, this one also has vertical asymptotes there. Now, notice here that our y value here is 18. And over here on this one, our y value was 1. So comparatively speaking, this one has not been stretched out vertically where the other one has. Let's look at this last one. This one's not going to work because I have vertical asymptotes only at 2 pi and negative 2 pi. So this can't be it because we need them at 2 pi, pi, 0, negative pi, and negative 2 pi. So it can't be D. So we know it's not this one. And so again, because the y coordinate here is 18 and this one is 1, this one has had the vertical stretch of 9. So it's going to be B. Let's go with B and check our answer here. Well done. We move on? Oh no, we don't move on. Okay, use the graph to determine the domain. So what is a domain? Well, we know that the only thing you can't plug in is when sine, again, when sine is 0, right? And sine is 0 at 0, pi, 2 pi, 3 pi, 4 pi. So any multiple of pi, we can't plug in. So let's see what these say. This first one here says the domain, well, all real numbers can't be that. There's certain things we can't plug in. This says all x's such that x cannot be k times pi where k is an integer. So this means all multiples of pi. So that should be it. This is all multiples of pi over 4. That's not it, right? Because none of these are fractions. This is all multiples of pi over 2, so it can't be that either. So it's got to be B. All right, so use a graph to determine the range. So if you look at these graphs, remember these go forever, right? They go up and down forever. So every y value possible will come out positive and every negative y value will come out. So it's got to be all real numbers. Check the answer. Next question. All right, so next question, we want to graph tangent of pi over 2 times x. So the standard thing to do on tangent is we first want to figure out where we have our vertical asymptote. So we're going to take the inside of this, pi over 2 x, and we want to set it equal to the 2 standard endpoints, or 2 standard places that we have vertical asymptotes for tangent, which is at negative pi over 2 and pi over 2. So this is very similar to like when we're doing a sine function. We set the inside of this equal to 0 and 2 pi. Well, for tangent, we set it equal to negative pi over 2 and pi over 2, and then we solve for x. So if I just, let me see, I can divide this by pi over 2, divide this by pi over 2, goes away, we get x must be here, that's negative 1. And if we divide by pi over 2 here, divide by pi over 2 here, we get x equals 1 here. So negative 1 and 1. So when we go to graph this, we should have at 1, oh, sorry, that's not 1, that's negative 1. So at 1 and negative 1, we should have vertical asymptotes. And then right in the middle, that's at 0, we should have the x-intercept, and then we know that the graph must go like this and then kind of go like that. So just by looking at these, it can't be this. All right, let's look at this one here. So let's see, we have vertical asymptotes happening at, let's see, if this is 4, that's 3, that's 2, that's 1. So how far apart are these? The distance between, oh, I didn't mean to do that. I accidentally cleared it. Hold on. I need to get it back. There we go. So between these, the distance between here and here is 2. So it looks like that's what's happening here. We have, here's 0, here's 1, here's negative 1, here's 3. So the distance between here and here is 2, distance between here and here is 2. So this is looking pretty good. Let's take a look at the other ones and see what they look like. So A is looking like a pretty good choice. How about for B? Get rid of that. So for B, all right, so notice these are, this is 2 pi, so that would be pi. And so these are not happening at 1 and negative 1. That's what we need. So it can't be this because this, our x-axis has pi on it, so it can't be that. And then this one, I think the same thing. We have pi's on our x-axis and we need it to be 1 and negative 1. So it's got to be that first option here. Okay. Now, okay, determine the domain. So remember, if we look at this graph, I'll bring up this bigger one again. Let me clear out all the other stuff. This was happening at 1. This was happening at 3. This was happening at negative 1. This was happening at negative 3. So these are all these are all odd numbers, right? So you have 1, 3, the next one would be 5. So which of these is that answer? They're all odd numbers. So here, this is not right. It can't be where k is, it's not k times pi, because that would be like pi, 2 pi, 3 pi. We don't want that, right? We want this 1 times k, where k is an odd integer. So that would be like 1 times 1, 1 times 3, 1 times 5, 1 times 7. And then you could also do negative k. So 1 times negative 1, 1 times negative 3. So that should be it. And then that's not it because that's a fraction and it's not all real numbers because we definitely have vertical asymptotes. So it's got to be B here. Okay, let's see. And then domain, or sorry, range. Well, just like the previous problem, all y values were achieved. So we have all real numbers. All right, cotangent 1/3 x. So we can eliminate a few of these because, or at least one of them, we can eliminate that one because that looks like a tangent. So it could be this, could be this, could be this. So what we do here is we take the 1/3, and whenever you're doing cotangent, Instead of doing negative pi over 2 and pi over 2 like we did for tangent, we do 0 and we do pi for cotangent. And we solve for x, so I just multiply both sides by 3 here, we get 0. And then over here, we multiply both sides by 3 and we get 3 pi. So when we graph this, let's see, at 0, we have vertical asymptote. And then at 3 pi, we have a vertical asymptote. And that means that at -3, we would also have a vertical asymptote because it looks like the distance between these is 3 pi. That's our period, I guess you could say. And then we know it's a cotangent, so we know it must must do this. Oops. You put, oh yeah. Okay, there we go. So put the x-intercept, must go like, ooh, that's terrible. Like that, and then another x-intercept here. And so this would be 3 pi over 2. So the distance from here to here, half of it would be 3 pi over 2. And then this would be -3 pi over 2. Okay, so let's see which of these it is. This one does not look right because the vertical asymptote's at 2 pi and -2 pi, so that's not it. This one, this is looking pretty good. Let me see, we can look at this one here. This one's not going to work because we have 2 pi, that looks like pi, 0, so that's not it because it's 0 and 3 pi. It's going to have to be this one here. So 6 pi, there's 3 pi, there's 0, there's -3 pi, so this is it. All right, so take that. Okay, now we want to know the domain. So it's everything except for multiples of 3 pi. So that should be this option right here, all multiples of 3 pi. And then the range should be everything again because it's a cotangent function. All right, so now we want to graph 5 cosecant of 1/8 x. So the way I'm going to do this is I'm actually going to look at 5, and the reciprocal of cosecant is sine, so sine of 1/8 x. And so I'm going to graph that function first. So to graph that, the amplitude of this is 5, and then I can find the period, and that would be 2 pi divided by that number in front over 1/8. And now if we flip that fraction up, it becomes 16 pi, so a period of 16 pi. So what I did in class is I said, all right, let's take the 1/8 x, let's set it equal to 0. Let's take the 1/8 x, let's set it equal to 2 pi. And if we solve this first one, multiply both sides by 8, we get 0. Multiply both sides by 8, here we get 16 pi. So now what I'm going to do is start to try and draw this. We have a starting position at 0 and an ending position here at 16 pi. And then I go and get my points. So I'll go halfway is 8 pi. Halfway here is 4 pi. And halfway here is 12 pi. I know it's a sine function with an amplitude of 5. So here's 5, here's -5. Amplitude of 5, and it's a sine function. Sine functions have x-intercepts at the beginning, middle, and end. And then it should go like this because it hasn't been reflected or flipped or anything. And then back. Okay, that's the sine. Now what we need to do is we need to, everywhere it hits the x-axis, draw a vertical asymptote because we're trying to graph the reciprocal function cosecant. And now from here, we draw our little u's that touch the tip there. And then here it goes like this, like that. All right, so which of these is it? All right, this one, if we just look at, let's kind of just look at these. Notice that this vertical here is at 0. So our little parabola should never cross the y-axis. And here you can see the little parabola crosses the y-axis, so it can't be this. This one, the little parabola crosses the y-axis down here. It can't be that because that doesn't happen here. So it can't be those two. And then here, this one, it goes down here to the right of the y-axis. We actually need to go up. So it can't be that. It has to be this first one. We'll go with that. All right, now what is a domain? Well, anywhere where we have vertical asymptote, which is at 0, 8 pi, 16 pi. So these are all multiples of 8 pi. That would be here. Everything except multiples of 8 pi. And then the range. Now the range you have to be careful with because the range is only the y values that it takes on. So we know that we get y values from 5 up and -5 down. So the way we'd say that is that the y value must be less than or equal to -5. That's this. Y must be less than or equal to -5. And then the y must be greater than or equal to 5 would be that. So it's got to be this first one. And that's it. Okay, next one, we want to graph -8 cosecant of pi over 3x. So I'm going to start this by actually graphing -8 sine, which is the reciprocal of this, of pi over 3x. All right, so amplitude is 8, but it's going to be flipped over the x-axis because of the negative in front of the 8. We get the period. The period we get by taking 2 pi and dividing it by pi over 3, which is the same as 2 pi times 3 over pi. The reciprocal, the pi's cancel, and we just get 6 here. To get the starting and stopping, we can take pi over 3x, set it to 0, take pi over 3x and set it to 2 pi. Multiply both sides by pi by the reciprocal or divide by pi over 3. We're still going to get 0 here. Here, I'll show you what I'm going to do here. I'm going to multiply by 3 over pi on the left, multiply by 3 over pi on the right. Pi's cancel, 3's cancel, we just get x. Over here, pi's cancel, and we get 6. So when I go to graph this, I know that we have it 6, and then halfway is 3, and then we have 1.5. And then this is 4.5. It is a sine function, has an amplitude of 8. So let's say that's 8, and this is -8. We know sine functions have x-intercepts at beginning, middle, and end. And then it's supposed to start by going up, but because it's flipped over, it's going to start by going down, and then back up, and then back down. Anywhere where it hits the x-axis is where we have the vertical asymptote, because we're actually trying to graph cosecant. And then right here, we'll have a parabola that touches there. And then here we have parabola that touches here. All right, so could it be this first one? No, because to the right of the y-axis, it goes up first, and for us, it goes down. It could be this one, because it goes down here. Can't be this, because it has like 2 pi on the x-axis. This doesn't make any sense. Can't be this, because right here in the middle, the parabola goes through the y-axis, which doesn't happen here. So it's got to be this one. Okay, the domain is everything except for, let's see, we have verticals at 0, 3, 6, 9, so all multiples of 3. And then our range is everything bigger than 8 and less than or equal to, bigger than or equal to 8 or less than or equal to -8. So it should be this one right here. There we go. All right, so we're going to do this one now. We're now doing a secant function. So to do a secant, we're actually going to look at cosine of 2 pi over 3x, and then we have a +2 at the end. Remember, that's going to move the whole thing up 2. Amplitude of this is 1 because there's a 1 in front of that cosine. And the period we could get, but I'm just going to get the starting and ending points. So set that to 0. Set that to 2 pi. So the first one, when you divide through by 2 pi over 3, you just get 0. Over here, there are different ways you could do this. I'm going to multiply by 3 over 2 pi, the reciprocal. Do the same thing over here, 3 over 2 pi like that. 3's cancel, 2's cancel, pi's cancel, you just get x. Over here, pi's cancel, 2's cancel, you just get 3. So we know when we graph this, it's going to start at 0. It's going to end at 3. Halfway is 1.5. Half of that, 0.75. And then here, this will be 2.25. Now, be careful. This is a cosine function. So cosine functions have x-intercepts here and here. And here we should have an amplitude of 1. So here's 1, here's -1. We're not flipping over the x-axis. So we're just going to start the normal cosine function. I'm going to draw it dotted. It's going to go like a frown. And then it's going to go like a smile. And then it comes back up like that. Now, we do have to take the whole thing and shift it up 2. Okay, so when we take this whole thing and shift it up 2, every point goes up 2. So let me make this 2 and make that 3. So that point moves up to here. This point moves up 2 to here. This point that was here moves up 2, which puts it here. This point moves up 2, which moves it here. And this point moves up 2, which puts it there. And then I can draw like this. And then our verticals would have come into play right here through those x-intercepts, like that. And now we draw our secant function, which is going to be a parabola right there between those verticals. And then we have this parabola here that goes like that. And it actually continues on the other side also. And then over here we have a parabola that goes like this, and then it continues over here. So let's see which of these it can be. Can't be this, because the parabola that we have here goes through the y-axis is going up, not down. Can't be here, because here our parabola to the right of the y-axis goes up and to the left of the y-axis goes down. This looks like it could be it right here, because we've got this going through the y-axis like this, but then so does this one. So what we really need to determine is how high up this is. So this is 1, 2, 3. That's where it is up here at 3. So let me zoom in on this. You can see that this little parabola kind of looking thing starts here at 1, 2, 3. So that looks pretty good. Let's just double check with this one. Make sure it's not this one. So for this one, you can see that little open parabola starts at 1. So it can't be that, because ours needs to be up here at 3. So it's got to be this one. Okay, now the domain. So here we have problems at 0.75, at 2.25. So you need to look at 0.75. I think the easiest way is to just remember that 0.75 really means 3/4. And then this one right here would be a multiple of 3/4, because it's going up by the distance between these two verticals is going to be, what is it, 1.5? So 1.5. So the next one, these should all be multiples of 3/4. Okay. And finally, the range. So it's everything from 3 up and everything from -1 down. So it's everything less than -1, less than or equal to -1, greater than or equal to 3. All right. Okay, on the next one, we have 1/4 cotangent. All right, so because it's a cotangent and there's not a negative, I can already eliminate this guy, because that looks more like a tangent. All right, because it's cotangent, I'm going to take that 1/5 x, set it equal to 0, and 1/5 x and set it equal to pi. We get x is 0 here, and we get x is 5 pi here. So our graph is going to look like this. At 0, we have a vertical asymptote. And then at 5 pi, we have another vertical asymptote. Right in the middle here, we will have our x-intercept. And then we have, the graph should look like this. But we have a +1, and then the 1/4 makes it scaled down. That shrinks it, so it makes it kind of flatter. So it's gonna be more like this and like that. And then we have to move the whole thing up. So I think what I'm going to do is just Move that point up 1. So that's really our graph right there. And then it's kind of flattened out like that. All right, so let's see which of these it could be. 5 pi, so let's take a look at this one. So that moved up 1. We have verticals at 0, 5, and 10. This looks pretty good. It moved up 1. This looks like it's pretty good. No, it's not that one. Let's look at this one. This one, yeah, this is 10 pi. This is, let's see if this is 1, 2, 3, 4. 2. Yeah, that's not right because 5 pi would be right in the middle. That can't be that one. Let's look at this one. Okay, this one looks like, it looks like 10 pi or 10 pi, 5 pi, 0. This looks like it could be this also. And this is moved up 1. So it really, it's coming down between that one, which looks really kind of stretched out vertical, compared to this one, which is identical, but it's not as stretched out as the other one. This one looks a little flatter here, and that's what the 1/4 is doing. It's kind of flattening it out. So I'm going to go with that option. Go with A. All right. Okay, so look at where we have problems at 0, 5 pi, next one would be 10 pi. So these are all multiples of 5 pi, which is this last option. And the range should be everything because it's a cotangent function. Every y value is achieved. All right, next one is cosecant, -5 cosecant of 1/3 x plus 2. All right, so I'm going to graph -5 sine of 1/3 x and then plus 2. So I'm just going to go with the start and stop because I'm going to trust that you understand what the period is 5. It's been flipped over the x-axis and all that stuff, shifted up 2. So we get one solution here of 0, and then this one, we multiply both sides by 3, we get 6 pi. So we have here 0 and at 6 pi. And then here, this would be 3 pi. This would be, I'll do 1.5 pi, that's fine. And this would be 4.5 pi. All right, it's a sine function because we're trying to graph cosecant and sine. We have x-intercepts here, here, here. Amplitude here is 5, -5. Okay, now we're supposed to flip it over the x-axis. So instead of it going up and down and up, it's going to go down and up and down. So it should go like this, that. And we have to move the whole thing up 2. So our vertical asymptotes are going to be here. But our whole graph needs to go up 2. So I'm just going to do this quickly. It's everything goes up 2. So, 2 units up there. This one goes up 2. 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 So our graph looks more like this. And so the cosecant function should be just the parabola here. That little, I say parabola, it's not a parabola, but it looks like a parabola. All right, so which one of these could it be? Could it be this one? Yes, looks like that. Well, no, because that's 2 pi. That would be pi. No, that's not going to work because we need 6 pi. Could be this one, but wait a minute. That parabola looking thing is above the x-axis, and here it's not. So it can't be that. Can't be this because this parabola looking thing goes through the middle and ours doesn't, through the y-axis. This looks like it. Let's look at it just to be sure. We have 6 pi, 3 pi, that works, 0. This looks like, yeah, it looks like it came up. Yeah, this looks like it. Good. Okay, now domain 0, 3 pi, 6 pi, all multiples of 3 pi. Cannot be, x cannot be a multiple of 3 pi. And the range, let's see, everything smaller than, now remember, this was 5, then it got moved up 2. So it's everything bigger than 7. This was -5, but it got moved up 2. That's -3. So it's going to be anything bigger than or equal to 7 and less than or equal to -3. All right, so this last one's a little tricky because it's actually giving us a piecewise function. It's saying that our function looks like the tangent function if you're looking between 0 and pi over 2. At pi over 2, the function spits out 0. And between pi over 2 and pi, it looks like the secant function. So let's just focus on this first part, that it has to look like tangent whenever you are between 0 and pi over 2. So, excuse me, between 0 and pi over 2, we have to look like tangent, and we know tangent does this, right? So it could be that one. It cannot be this one because tangent's supposed to go through right there at 0, so it cannot be this. It could be this one because tangent would do that, okay? So it's either got to be the first one or the third one. Now, the next thing is that at pi over 2, we should get 0. So we know it's not this one. So at pi over 2, we have 0. It's a dot. And over here on this one, at pi over 2, we have 0. So that doesn't really tell us anything. The last thing is the fact that, excuse me, geez, between pi over 2 and pi, it's got to look like secant. Secant is 1 over cosine, right? So what we normally do to graph secant is we graph a cosine function real quick. Okay. And when we graph cosine, we have x-intercepts here and here. And it goes like this. This is what cosine does. Comes down, comes back up, goes like that. And then anywhere we have x-intercepts, we have vertical asymptotes on the secant function. And then we have these little parabolas that go like that, and then like this, and then like this, okay? So we are only looking between pi over 2 and pi, so we're only looking in this little window right here and forgetting everything else. And so our graph should look like this, which looks like this and not this, all right? So it's got to be A. That's a tricky problem, different problem. Weird problem, I guess you could say. Final check. Is that all they want there? Oh, okay, I'm done. All right, that's it for that one.